Okay, so this video is going to be about section 9.4, which is going to be properties of tangents, and there is going to be a quiz after this section. So again, we'll review the definition of what it means to be a tangent, and then we'll talk about what's special about these tangent lines. A tangent line intersects a circle at exactly one point. Okay? Again, if it intersects more than once, it's going to become a secant. Okay? And the point where that tangent line touches the circle is called the point of tangency. So again, you have your red circle, your blue tangent line, and this right here that I'm highlighting even more is now your point of tangency. So if a line is tangent to a circle, then the line is perpendicular to the radius at the point of tangency. So again, if I have a tangent line and there's my point of tangency and I draw my radius, that means that those two things are then going to be perpendicular. Again, something to keep in mind if you're given a problem and again, you have no numbers inside of it and you're asked to find the measure of something, again, this could be the key to that problem. Okay, and if two segments from the same exterior point are tangent to a circle, then they are, that should say congruent. Okay, so they're congruent, which means again with that picture on the left-hand side here, hey, AB is tangent to the circle and BC is tangent to the circle and they meet at that point B. Again, AB is going to be congruent to BC. If a polygon is circumscribed around a circle, circumscribed just means it's on the outside of the circle. Inscribed would be the inside of the circle. So in a previous lesson, we talked about a polygon being inscribed inside the circle. Now, again, we're talking about something being outside the circle. So in the picture below, that triangle is outside the circle. So if a polygon is circumscribed around a circle, then all sides are tangent. Okay, meaning that AB is going to be tangent to the circle, BC is tangent to the circle, and AC is tangent to the circle. Okay, and the rule that's going to help us here in a lot of our problems, the measure of an angle formed by a tangent and a chord is equal to half the measure of the intercepted arc. So this is very similar to when you have an inscribed angle. Again, remember with an inscribed angle, your vertice lies on the circle itself. So again, here the vertice is lying on the circle itself, so it's going to follow that same pattern. So in this case, the measure of angle 1 is going to be 1/2 of the arc that it intercepts. And the arc that it intercepts is, let me change my color here, I can't really see it, is this red one here. So it's going to be 1/2 of AB. On the other side, if I wanted to know the measure of angle 2, this time it intercepts a major arc. And the major arc that it intercepts would be ACB. So the measure of angle 2 would be 1/2 the measure of arc ABC. So again, if you're given the angle and you want to find the arc, we're going to multiply by 2. If you're given the arc and you want to find the angle, you're going to divide by 2. So let's take a look at some examples that go along with all those things that we just spoke about. So in circle O, PT is tangent to the circle, and OT is 9, and the radius is 6. Find PT in simplest radical form. Okay, so we're looking for PT here, which I'll call X, and it tells me that the radius of the circle is 6, and right now the radius, that's part of that picture, is the line segment OP, so OP is going to be 6, and they tell me that OT is 9. Okay, so how am I going to find X here? Again, what's important is that we have a tangent and a radius. And when you have that tangent and the radius, they're perpendicular, which means that that triangle is going to be a right triangle. And when I have the missing side of a right triangle, we're going to use the Pythagorean theorem. So we're going to do a squared plus b squared equals c squared. And once again, always have to put the side in that's opposite the right angle in for c. Your other two don't matter. So we'll do x squared plus 6 squared equals 9 squared. Or 6 squared is 36, 9 squared is 81. So we have x squared plus 36 equals 81. We'll subtract 36 from both sides, and x squared is going to equal 45. Again, directions say simplest radical form. Okay, so now again, the opposite of squaring something is taking the square root. So the square root of x squared is x, and right now I'm going to leave that as the square root of 45. So again, we want it in simplest radical form, which means I'm looking for the perfect square that's a factor of 45. Again, your perfect square is 1, which is never going to help you in this case. 4, 9, 16, 25, 36, etc. Okay, your biggest perfect square that's going to go into 45 is going to be 9. So I'm going to break this down into radical 9, and 9 times what would give me 45? It would be 5. I know what the square root of 9 is though. It's 3, and then I'll tack on the radical 5. So 3 radical 5 is going to be your length of PT. Okay, question 2, now they want to know if ML is tangent to the circle N at L. So we want to know if this is the point of tangency, and we're going to explain why. Well, if this is tangent, that means that these two things, that radius and that other line, so both the segments that I highlighted in red there, need to form a right angle. So how can I determine if they form a right angle? I have a whole triangle here, and now I have all 3 sides of the triangle. So if all 3 sides form the Pythagorean theorem, that means that that's going to end up being a right angle. So we'll do a squared plus b squared equals c squared. Again, we want to show that this angle right here is the right angle, which means I have to chuck in the side opposite that for c. Doesn't matter how you plug in the 7 and the 24. So I want to know, does 7 squared plus 24 squared equal 25 squared? If it does, it's a right triangle, and then that's a right angle. If it doesn't, then that can't be a right angle, and then it wouldn't be. So 7 squared is 49. 24 squared is 576. And 25 squared is 625. So now on the left-hand side, I'm just going to add together 49 plus 576. And when you do that, you're going to get 625. And if I bring down the 625 on the right-hand side, 625 does equal 625. Okay, so yes, it is tangent. Because it forms a right angle. And again, you know it forms a right angle because you just used the Pythagorean theorem, which is only good for a right triangle. For number 3, we want to find the value of x if AB and BC are tangent to circle D. Okay, so again, if those 2 lines are tangent and they meet at that same point B, that means that those 2 pieces are equal. So we want to just set 5x plus 23 equal to 8x minus 19. Again, it doesn't matter what you do first here. I'll subtract 5x from both sides, which will leave me with 23, which equals 3x minus 19. I'll add 19 to both sides, and when you add 23 plus 19, you're going to get an answer of 42. So 42 is going to equal 3x. Divide both sides by 3, and when you do 42 divided by 3, you should get an answer of 14. The question asked you to find the value of x. You found x. You don't need to plug it back in. You're done. Okay, so jumping off of that now to number 4, now we want to find the perimeter of triangle DEF. So DEF is this entire triangle that I'm highlighting in red. So again, we're just going to kind of hop off of 3 here, and we're going to talk about the fact that because the triangle is circumscribed around that circle, that means that all your sides are tangent. And if they're tangent, that means that here at E, that means that this piece is going to have to be congruent to that piece, which means if that one side is 16, this side is going to be 16. And then the same thing's going to happen down at F. If this side is 9.5, that means this side is going to be 9.5. And the same thing's going to happen at D. If this piece up here is 11, that means that this piece over here is 11. So now to find the perimeter, we're just going to add all the sides together. So I'm going to add all these pieces together, and that will give me the entire distance around the entire triangle. So 11 plus 16 plus 16 plus 9.5 plus 9.5 plus 11. Okay, so when you add all those together inside of your calculator, you should get an answer of 73. Okay, so the perimeter of that big triangle then is going to be 73. For number 5, we want to find 3 different things. The first thing that we want to find is arc AEB. Again, AEB is going to be a major arc. And again, if you go around the entire circle, AEB is that arc there. Okay, so again, we have a tangent line and a chord, and then we have this angle here is going to be 133. And again, that means that that angle is 1/2 of the arc that it intercepts. So the arc that intercepts is actually the one that I just highlighted. So again, to go from the angle to the arc, we're going to multiply by 2. So arc AEB is going to be 2 times 133, and 2 times 133 is going to be 266. Okay, then the next one that we want to find is just AB. And AB, again, would be a minor arc. It's less than 180. Okay, and AB would be half of this angle right here. The problem is I don't know what that angle is. However, I can easily find it because this is a straight line. And there's 180 degrees in a straight line. So if I take my 180 and subtract out the 33 that I've used for the angle that's adjacent to that, that's going to leave me with an answer of 90. Nope, not 90. That is going to leave me with an answer of, would help if I did this before I started talking, 47. Hey, yep, 47. So this angle right here is going to be 47. Okay, which means that now to go from the angle to the arc this time, again, we're going to multiply by 2. So arc AB is going to be 2 times 47, which is 94. Okay, also probably the easier way to do it. I just found above that this was 266. If I take that 266 and the purple arc all together, they would form an entire circle, so they would be 360. So I also could have done 360 minus 266 to get that answer. Okay, and then the next thing that we need is the measure of angle BAF, which I kind of just indirectly found in that last problem. Angle BAF is going to be 47 degrees. Again, that's either it forms a linear pair with that 133, or again, it's 1/2 of the intercepted arc. If the intercepted arc was 94, half of 94 would be 47. So there's more than one way to do these problems. Okay, for number 6, we have in the diagram shown BC is tangent to circle A at C. And if AB is 17 and BC is 15, then which of the following is the length of the radius of the circle? So again, we're looking for the radius of the circle, which is going to end up being that purple dotted line that I just drew. And again, if you have a tangent line and a radius, that means that this has to be perpendicular. So once again, it has to form a right angle. So if AB is 17, BC is 15, we want to know the length of the radius. So again, how we're going to do this is the Pythagorean theorem. Side opposite that right angle has to go in for C. The rest doesn't matter. So I'm going to have A squared plus B squared equals C squared. So that 17 has to go in for C. It doesn't matter how you plug in the X and the 15. So I'm going to have X squared plus 15 squared equals 17 squared. 15 squared should give me an answer of 225, and 17 squared should give me an answer of 289. We'll subtract 225 from both sides, and that's going to leave me with x squared equals 64. The opposite of squaring something is taking the square root, and the square root of 64 is 8, so choice B is going to be my answer there. Okay, and our last problem, we want to use the picture to determine which statement is not always true. So let's go through them here and see what happens. So the first one is that angle ABC is congruent to ADC. ABC is this angle here, and ACD, let's use a different color, ACD is that angle there. Okay, well, for the purple angle, for angle ABC, that is an angle that is intercepting a semicircle here. Your semicircle is 180, which means that half of 180, that's an inscribed angle, is going to be 90. So angle ABC is 90 degrees. So now let's look at ACD. ACD, you have a tangent line, and technically you have a diameter, but half the diameter would be just the radius. So you have a tangent line and a radius. A tangent line and a radius are perpendicular, which means that angle is also 90. So choice number 1 is absolutely true. Choice number 2, I have ACB is congruent to angle BCD. ACB is going to be this angle here. Again, ACB. And again, I'll change colors just to try to make it a little clearer here. And then I have BCD, which is right here. Okay, so the only thing that I can say about those two angles is that they are half of their intercepted arcs, and they're not intercepting the same arc. The red angle intercepts arc AB, and the orange angle intersects arc BC. And we have no idea if AB is congruent to BC. The two arcs are congruent. So right now, I'm thinking that that's going to be my choice because I can't say anything special about those angles. Nothing's perpendicular there. There's nothing special that I can say. But let's look at the other choices and just make sure that nothing else is happening with the rest of them. So for choice 3, I have angle BAC. So BAC is this angle right here. And then DCB, again, I'll change my color here. DCB is this angle here. Okay, again, both of those have their vertex point on the circle, so they're both going to be half of the arc that they intercept. So my red angle intersects arc BC right here. If I switch back to purple, again, the purple angle intersects there and there, which is also BC. So both those angles intercept the same arc, and they're both going to be half of that arc, which means that those are going to be congruent. Okay, and then for my last choice, I have angle CBA. CBA, again, is this angle here, which again, from the problem up above, that's half. There's a semicircle there, so that's an inscribed angle. So that one's going to be 90. So CBA is going to be 90. And then I need to know if angle AEC is also going to be 90. I'll switch to green this time. So AEC is here. Okay, and this time, again, you have a diameter and a chord that form that angle, which means that that is going to be a right angle as well. So that one is also going to be 90. So 90 equals 90. So we were right when we first chose 2. 2 is the correct answer there.